In this video, we're going to show you how to use Excel to calculate binomial probabilities. Suppose we have a random variable, a binomial random variable x. Now, for binomial random variable, we have two parameters. One is called the number of trials, n. The other is the probability of success, p. So let's look at an example. Suppose n is equal to 16 and p is equal to 0.45. As you can see, this is a graphical representation of the probabilities associated with each of the possible values of x. Given the fact that n is 16, x would take on actually 17 possible values from 0 to 16. And the length of the bar represents the probabilities, as you can see on this side, where we actually calculate the probability for each of the possible value of x. So if you put the cursor key on one of those, and you can look at the formula, this is actually a formula that is that we use a Excel function to calculate. So what we're going to do is learn how to do that. Okay, now we can actually get a sense of how the probability changes if the number of trials or the probability of success change. So for example, suppose we have n equal to 18 and p is 0.65, then you can see that the probability actually would change a little bit, and the higher bar would shift to the right, where when x is equal to 10, 11, 12, 13, and so on, actually has higher probability. And the reason why that is the case, of course, is because of the fact that the p is bigger than 0.5. Now, using this example, we would then be able to calculate the probability of x equal to a particular value when x is binomial. So for our first example, p, we want to calculate the probability of x equal to 8. So how do we do that in Excel? What we have to do is we say equal sign binom, B-I-N-O-M, .dist. So that is the Excel function that allows us to calculate the binomial probability, bracket. And for this Excel function, we need to enter 4 things. The first one is the value of the random variable that we want to evaluate the probability at. So in this case, because of the fact that we want to calculate probability of x equal to 8, we put 8 first. And then the next 2 numbers are the 2 parameters of the binomial random variable. One is n, which is 18. The other one is the probability of success, which is 0.65. And the last things that we need to put in is to tell Excel whether we are calculating the probability mass function, that means the value of the probability at x equal to a particular value, or a cumulative distribution function. In that case, is all the probability up to the point of the evaluation. So in this case, because of the fact that we want to calculate p x equal to 8, so we put in false, F-A-L-S-E, right? So if you want to calculate probability for one number, this is the way that we enter them, right? Binom.dist 8, 18, 0.65, false. And the number, the probability is equal to 0.0385. So if you look at the graph here, that's what we're looking at, right? And it looks okay to us. Now, in order for us to use binomial probabilities, we need to know how to calculate probability for the 5 scenario. If you know how to calculate these 5 scenarios, then you know everything that you need to know in calculating binomial probabilities. The first one is probability of less than 8. The next one is probability of more than, at least, at most, and in between. So those are the 5 possible scenarios in calculating binomial probability, and we need to know how to calculate each one. Now let's try the first one. The first one is less than 8. So what does that mean? Well, it means that if you have a binomial random variable, you want to calculate the probability that x is less than 8. So it could be 0, it could be 1, all the way up to 7, but not including 8. So what we're looking at here, as you can see here, these are the probabilities that we want to calculate, and we want to add them all up. Now, one way of doing it, of course, is that we can use what we learned and we calculate probability of x equals 0, probability of x equals 1, probability of x equals 2, and so on, and all the way up to 7 and add them up. Another way of doing it, of course, is to use the cumulative function, which I just talked about, and we can now try it. So we can actually do binom, B-I-N-O-M, .dist, bracket, and we want to calculate all the way up to 7, right? So we enter 7, 18, comma, 0.65, comma, because of the fact that we want to accumulate all the probability up to 7, so this time we would enter true rather than false. Okay, so that's the function we would enter, and the number looks really small, right? 0.0, and you can actually see that this is actually really small. Now, if you want to give the number a little 3 or 4 decimal places, you can actually see that this number is not actually 0, it's actually 0.0212. Now the next one, more than. So more than means that x can be 6, 7, 8, 9, 10, 11, all the way to 18, right? So you can, as you can see, when you do binomial probability, it's actually really useful if you actually write down 0 to 18 and then ask yourself, what are the numbers that we want to calculate the probabilities at? So more than 5 means from 6 to 18, but 5 is not included. And as you can see, that these numbers is going to be very close to 1. So how do we do that? Well, the function would not give you the probabilities directly. So we have to calculate the number indirectly, in the sense that we need to calculate the probability of 0 to 5 and then 1 minus that. So that's what we have to do. So in terms of Excel, we would say equal 1 minus the probability of 0 to 5. So we say binom.dist 5, because we want to calculate the probability up to 5. 0.8 is the, 18 is the number of trials. 0.65 is the probability of success. And 2, because we want the probability to accumulate from 0 to 5. Okay, so that would be the function that we want to enter in order to calculate the probability, right? So, and as I said, the number, if you can actually look at it, is very close to 1. Again, if you give this number more decimal places, you can actually see that this is actually equal to 0.9986. The next one that we need to learn is at least 8. At least 8 means 8 is from 8 on all the way to 18, except this time 8 is also included, right? At least means 8 is included all the way to 18. So if 8 is included, how do we calculate the probability? As you can see here, it will be 1 minus the probability of 0 to 7, right? Because 8 is included, so we calculate 0 to 7 and 1 minus that. So again, how do we enter it? We enter it as 1 minus binom.dist bracket 7, 18.65, and again 2. So that's the way that we would calculate at least 8. And I'm going to format all of them with 4 decimal places so you can actually see what you need to do. When we calculate binomial probability, it's best that we show at least 3 decimal places. Now, the next one is at most 11. At most 11 means from 0 to 11, right? But no more than 11. So 0 to 11, but no more than 11. So how do we do that? Well, in this case, it's actually really straightforward. All you have to do is the cumulative probability from 0 to 11, right? So in terms of the Excel function, we will say equal sign binom.dist 11, 18.65, and 2. So with the exception of the first case, it's very likely that when we do these calculations that the last parameter is always 2, right? And so the probability is equal to 0.4594509. And if you look at the graph, it looks about right to us, right? It's probably half of the probabilities in the probability distribution. Now, the last one is the most challenging, is the most complicated one. What we want is we want to calculate probability of x between 4 and 9. Now, assume that 4 and 9s are inclusive. That means we include 4, we include 9. And if I really want to be precise, I would say I want to calculate probability of x between 4 and 9 inclusive. Okay, so again, if you look at the numbers, what we want is we want 4 and 9. That's what we want. So how do we calculate it? Well, we can definitely calculate 0 to 9. That's not a problem. We can also calculate the probability of 0 to 3, and the difference would be 4 to 9, right? So again, let me say that if you want to calculate probability of x between 4 to 9, it's best that we calculate the probability from 0 to 9 minus the probability from 0 to 3. Okay, so that's what we need to do. So we say, okay, let's calculate the probability of 0 to 9 first. So binom.dist, right, 9, 18.65, 2. Right, so that's the probability of x from 0 to 9. And now we have to take away the probability from 0 to 3. So minus binom.dist 3, 18.65. Okay, so that's how we enter them. And obviously I make a mistake here. And where is the mistake? Here we go. So it's in the name of the function. So what I have to do is to fix that. And here we go. Now, as you can see, it's really difficult to visualize how to enter the Excel functions if you don't have the number axis in front of you. So the best practice is to, when you calculate binomial probabilities, you should actually draw the number axis and then figure out what do you need to do, right? So in this case, you can actually see, if once I show you the number, you can actually see that the best way to calculate the probability between 4 to 9 is 0 to 9 minus 0 to 3. Okay? So if you understand how to calculate these 6 types of probability in binomial, you should be able to calculate probabilities in any situation for the case of binomial probabilities. So now let's turn to an example to demonstrate how these things can be applied in an example. So here's an example. Suppose we are given the fact that 55% of the people who purchase pet food online are under the age of 35. So if the question is this, if we randomly select 18 people who just purchase pet food online, if we randomly select 18 people, we would be able then answer the following 6 questions. The first question is, what is the probability that exactly 10 of the purchasers are under the age of 35? Now again, just to show you very quickly, the probability distribution of this binomial distribution with n equal to 18 and p equal to 0.55. We assume in this case that the random variable is binomial. How do we know that? Well, we need to check the 4 conditions. The fact that, if you select 18 people, there are 18 identical trials. The selection is independent because you're selecting 18 people from a very large population. The trials are identical with the same probabilities and have 2 possible outcomes. So in this case, what's the 2 possible outcomes? They're either under the age of 35 or not. So by checking the 4 conditions, you can confirm that this experiment is a binomial experiment, and therefore the random variable that we're going to define to be x is the number of purchasers who so distribution scale towards a larger number just a little bit. Okay, so how do we calculate the first one? What's the probability that exactly 10 of the purchasers are under the age of 35? Well, we just want to calculate the probability of x equal to 10. Right? So this is actually probability of x equal to 10 if x is the number of purchases under 35. So if I really want to be exact, I would say let x equal to the number of purchasers who are under the age of 35. So how do we calculate that? Well, since we are just looking at the probability of x equal to 10, so what we can do is we enter binom.dist x equal to 10. So enter 10 here. What's n? N is equal to 18 because we select 18 people. And the probability of success in this case is 0.55. And because of the fact that we just want to have the probability at that particular point, so we're going to enter false. Okay, and that's the probability. And let's just make it into 4 decimal places. Okay, so x is binomial, n equal to, let me just write this down for you, n equal to 18 and p equal to 0.55. Now, the next one, what is the probability that less than 10 of the purchasers are under the age of 35? Less than 10. So again, let's just look at the number axis. Less than 10 means from 0, because 0 is not in the graph, by the way, because it's too small, n is equal to 18. So, but we should actually just keep that in mind, all the way to 8 to 10, but 10 is not included because it's less than 10. So it's from 0 to 9. So this is actually x is less than 10, if we write it down mathematically. And how do we calculate this? Well, we calculate by just calculating binom.dist, and less than 10 means up to 9, so 9, 18.55, and 2, because we want the probability accumulated all the way to 9. Right, and the probability is 0.4222. Now the next one, what's the probability that more than 12 are under the age of 35? So more than 12 is probability of x is bigger than 12. More than 12, x is bigger than 12. So how do we do that? Again, if you use the number axis, more than 12 means 13, 14, all the way to 18, but 12 is not included, right? So how do we calculate that? We have no way of calculating this directly. So what we can do is we can calculate 0 to 12, and that will, and then 1 minus that, right? So what we'll say is 1 minus binom.dist 12, 18.55, and 2. And 1 minus that number would give us the probability of 13 onward to 18. Okay, and the number is 0.1077. So the next one, what's the probability that at most 8 of the purchasers are under the age of 35? So what are we looking at? We're looking at probability of x is less than or equal to, right? Because at most means 8 is also included. So from 0 to 8. So that's easy enough, right? From 0 to 8, if you look at the number axis, right? So from 0 to 8. So remember, 0 is not showing up in the graph, but it should be part of it. So how do we do that? Become easier now. Binom.dist 8, 18.55, and 2. Okay, what's the percentage that at least 9 of the purchasers are under the age of 35? Now notice that we use the word percentage instead of probability. In this context, percentage is the same as probability, no difference. So even though that we are looking for percentage, we are actually looking for probability. Now, at least 9 means what? What's at least 9 means? At least 9 means x is bigger than or equal to 9. 9 is also included, right? So 9 is included, right? So 9 is included. So let's see. Oops. Just move this one. 9 is included all the way to 18, right? So how do we calculate that? So we calculate it by the accumulated probability from 0 to 8, and then 1 minus, right? So by looking at the number index and identify what we're looking for is actually pretty easy, right? So 1 minus binom.dist, and all the way up to 8, 18.55, and 2. And that probability is equal to 0.7473. The last one. What's the probability that between 7 and 13 purchasers are under the age of 35? So what we're looking for 7, including 7, inclusive, and also include 13. So 7 to 13, right? So 7 to 13. So this is what we're looking for. So the question is, how do we calculate? Well, we can accumulate from 0 to 13 minus from 0 to 6. right? So you can see in the number axis, very clearly if we draw the number axis, right? So it's binom.dist 13, right? All the way 0 to 13, 18.552. So that's the probability from 0 to 13, and we have to take away the probability from 0 to 6. So that would leave us with 7 to 13, right? So binom.dist 6.18, sorry, comma 18, comma 0.55, and 2. Okay, so again, as soon as you identify a random variable as binomial with n and p, you should be able to calculate any probabilities in Excel, using Excel and using the binom.dist function, right? So those are the 6 scenarios that you should know about. Thanks very much for your attention. Hopefully we will see you again in a future episode. Bye for now.